Hey, good evening. Welcome to Math for Kids number 58. Today we're going to look at two problems. We're only going to look at one really carefully. We're looking at Olympiad 24, problem number 4, and problem number 5 here. Problem number 5 is a little more difficult. The first one we're going to look at is based on Olympiad 24, problem number 4. So this one's actually not that hard, even though you've actually not ever seen a problem like this before, have you?
Haven't.
Have not. Okay, but actually this one's not too hard once you figure out what to do here. So here's the problem. The product of two positive integers is 1,000. Neither integer contains 0 as a digit. What are the two integers? Okay. So what are some problem-solving strategies when you have a problem that you don't know what to do or you've never seen before?
Well,
there's a couple different ones, so let's talk about them first.
In a problem like this, we need to find the product of two integers. You can just find the divisors of 1,000.
Okay, we could find the divisors of 1,000, so that's one way to go. What is another problem-solving strategy when you see a problem and you don't know how to do it or you've never seen it before? What's another strategy?
We could call the two positive integers x and y.
We could. That's not really a strategy, though. That's just something to do at the beginning of a problem. What's another strategy? When you have a problem and you don't know what to do, what can you do to help you understand the problem a little better?
We can write down what we know.
You can write down what you know. Anything else?
Another problem-solving strategies?
Yeah. How about make a simpler problem? Okay, 1,000. The trick on this problem is you have a number that has some zeros in it, and you're trying to make it write it as a product of two numbers that don't have any zeros. But 1,000 is definitely not the simplest number that has some zeros in it. What's a simple number that has some zeros in it?
10.
10. So can you write 10 as the product of two numbers that don't have any zeros in them?
Yes. 5 times 2.
Okay, 10 is 5 times 2. Okay.
Well, 1,000 is 500 times 2.
10 is 5 times 2. And you're right, 1,000, sorry, this pen's kind of running out, it's 500 times 2.
Here's another pen.
Okay. Thanks, sweetie. Okay.
Well,
but 1,000 is not the next simplest number.
Well, 100 is.
So look for, since we don't know what to do on 1,000, how about 100? Can you write 100 as a product of two numbers?
Yes, you can.
That don't have any zeros in them. Two integers, I mean.
25 times 4.
Okay, 25 times 4. Okay. Now, do you notice anything interesting about 10 equals 5 times 2 and 100 equals 25 times 4? What can you tell me about 25 and 4? They're special, those numbers.
25 and 4?
Yeah. What's special about 25 and what's special about 4?
Well, they're both perfect squares.
Right, so what is 25?
It's 5 times 5.
It's 5.
5 squared.
5 squared. What's 4?
2 squared.
2 squared. Okay. So 10 is 5 times 2. Can you write, is there any simpler way to write 10? Or is that as simple as it gets?
That's as simple as it gets.
Why?
Because 5 and 2 are not perfect squares.
But they are what?
No power. You can write it as
5 and 2 are what? What kind of numbers are 5 and 2?
Prime numbers.
Primes. 5 and 2 are prime numbers. So you factored 10 into two prime numbers. Okay? The product of two primes. That's as simple as it gets. Now you factored 100 into what? Here.
Into squares. Maybe the thousands.
Well, don't jump ahead to 1,000 yet. You factored 100 into the product of primes with powers. So what is that called when you do that?
Factoring.
Into
primes.
Factoring into primes, okay? So here, writing 10 as a product of primes, which you did without even really thinking about it, right? Was a good strategy. Writing 100 as a product of primes was also a good strategy. What can we say about 1,000?
It's 5 cubed. We think it's 5 cubed times 2 cubed.
Okay, we think it might be 5 cubed times 2 cubed. And we know, by the way, that 1,000 is just 10 times what?
Times 100.
And what's an even easier way to write it? 10 times?
10 times 5 squared times...
Yeah, well, what's 100?
Well, 100 is 5 squared times 2 squared.
Yeah, come on. What's 100? Really simple. What's the simplest thing you can think about with 100? You don't immediately think of 100 as being 5 squared times 2 squared. You think of 100 as being
10 times 10.
10 times 10. So 1,000 is 10 times 10 times 10, right?
It's 10 cubed. It's 10 cubed.
It's 10 cubed, but each 10 is 5 times 2. So this is 5 times 2 times 5 times 2 times 5 times 2, or 5 cubed times 2 cubed. Right?
Awesome. And by the way, the numbers are 125 times 8.
Okay. Now we're talking. 125 times 8. Now, is that equal to 1,000?
Well, 100 times 8 is 800. 20 times 8 is 20 times 8 is 200. No.
What's 20 times 8?
Well, 20 times 5 is 100 plus 80. It's 180.
How about
No.
third try? 20 times 8.
Whoopsie.
20 times 8, come on. You a little tired tonight?
Okay, it's 160.
Yes. Okay, so you have 800 plus 8 times 20 is 160. What's 8 times 5?
40.
So what's 800 plus 160 plus 40? 1,000. Okay, so good. So we figured it out. So one way to do a problem like this is to factor the number into primes. And the way we stumbled upon that is by going to a much easier question. 10 was 5 times 2. 100 was 25 times 4. That was nice. Okay, and that gave us the hint when we saw 5 squared times 2 squared to check 5 cubed times 2 cubed. Okay?
Yeah.
All right, good job. Now let's talk a little bit about the next problem. Okay, so here's just a little prep work for the second problem. And then we're going to talk about this, and then when we turn off the camera, we'll talk about the other problem. But here, these are two important questions. First question: if you're going 30 miles per hour, do you know what that means?
Yeah.
So you're like driving in a car, or in the problem, you're on a train, and the train's going 30 miles an hour. How long does it take to go 1 mile? What do you think? How would you approach this problem?
Well, how many feet is 1 mile? Well, it doesn't really help us.
Yeah, that doesn't really help. 5,280 feet are in a mile, but that's not going to help you. So you're going 30 miles in 1 hour. So how long does it take to go 1 mile when you're going 30 miles an hour? Well, you have a...
Making a chart is a good... We can do making a chart.
Okay, we can make a chart, or what's even another way that we just talked about?
We're going to go to a much simpler problem.
Okay, what's a really easy problem? How fast, what's another problem that would be a lot easier?
If you're going 1 mile an hour.
Okay, great. If you're going 1 mile an hour, how long does it take to go 1 mile?
Well, 1 mile an hour, so that's just going to take you one hour.
Right, 1 hour. Okay, great. If you're going 2 miles an hour, how long does it take to go 1 mile?
Half an hour.
Okay, how long is that?
Just 30 minutes.
Okay, if you're going 3 miles an hour, how long does it take to go 1 mile?
Well, I know how long. Four times.
You know how long?
If you're going 4 miles an hour, it's going to take 15 minutes.
Okay, awesome. Very good. If you're going 3 miles an hour, how long is it going to take? You're going to go 3 miles in 1 hour.
Well, 100... Well, you can't... Well, it's 60 minutes.
It's 60 minutes, right?
So
And you go 3 miles in 60
it's going to
minutes.
take 20 minutes.
Right, it's going to take 20 minutes. Okay, so you can see the pattern now. Now if you're going 30 miles an hour, how long does it take to go 1 mile?
Well, it's 2 minutes.
2 minutes, very good, because all you do is 60 minutes divided by 30 miles an hour. 2. Okay?
Cool.
All right, now, how about if you're going 15 miles an hour? How long is it going to take to go 1 mile?
Well, so 60 divided by 15, it's just going to be 4 minutes.
Okay, right. So this is a little slower than 30 miles an hour, right?
Yeah.
30 miles, so this is going to take longer. Okay, good job. So this is, just a basic concept from physics, and yeah, pretty simple math too.
Yep.
Okay, so now that's all I wanted to talk about with this one, and then when I turn off the camera, we'll do the harder problem. Okay.
Okay.
All right.